talk about. Okay, so here we're looking at surface area and volume of 3D objects, right? But now, before we begin, I need to state some of these things because they are important. So, in grade 8, what you mostly looked at, and you're still going to use some of the things in grade 8, from grade 8, is that you looked at how to calculate the surface area, the volume, the capacity of cubes, rectangular prisms, triangular prisms, right? Describing the interrelationship between surface area and volume, that's something you learned um, in grade 8, and solving problems involving surface area, volume, and capacity, and also to use and convert between appropriate SI units, including, right, from millimeter squared to centimeter squared to millimeter squared to kilometer squared, and so on and so forth, right? So this year, what you must be focused on, or what you need to be able to learn this year, is that you need to be solving problems using appropriate formula and conversions between SI units, right? So your last year's work in terms of converting between SI units becomes important as well now. And then also being able to calculate the surface area, volume, and capacity of cubes, rectangular prisms and triangular prisms, and cylinders. And then lastly, to investigate how doubling any or all the dimensions of right prisms and cylinders affect their volume. So that's actually something that's quite interesting that you should be able to do. And then something to look forward to in grade 10 is that you'll obviously be solving problems involving volume, surface area of solids, right? Studied in earlier grades, as well as spheres, pyramids, and cones, and combinations of those objects, which is quite interesting. But in grade 9, we need to look at certain terminology that we should know. And some of the terminology you can see now is about 2D and 3D, which just means to be in two-dimensional and three-dimensional. And then there's another one which is the polygon. And when we talk about a polygon, it is a 2D shape in which all the sides are made up of line segments, right? And then we talk about a solid, and it's an object that occupies space in three dimensions, right? And also, when we talk about a polyhedron, it's a solid in which all the surfaces are flat, or the faces are flat. And then when we talk about a prism, it's a solid with parallel equal bases. The bases are both polygons, meaning they are connected or they have sides that are made up of line segments. And then we look at right prisms. And these are some of the examples of the right prisms, as you can see, with the rectangular prism, a cube, a hexagonal prism, and so on, right? And a prism is which has sides that are right angles at to the base. And then we also have what we talk about when we talk about the face. It's just the flat surface of the prism. We have the edge where it's the faces of where they meet. The vertices, it's the edges. Then we have a cube, which is a solid with six equal square faces. A rectangular prism, a solid with six rectangular faces. And also, when we look at a triangle prism, it's a solid with two equal triangular faces and three rectangular faces. Then we have the cylinder, a solid with two equal circular faces, and so on, right? And then we have the net. And the net, remember, is whenever we break up a two-dimensional shape into a three-dimensional shape into a 2D shape, meaning we unfold the 3D shape into a 2D shape, right? And then we have surface area, which is what we're looking at, is the area taken by the net of a 3D shape, the sum of the areas of all the faces. And then we have the volume, and then that is the space taken by a 3D solid. To find volume, the area of the base is multiplied by the perpendicular height. This only works for right prisms. And then we have the capacity, right, which it's just the amount of liquid a 3D shape can hold. It is directly linked to volume. And those are the terminology. Now, starting off with surface area, right? So surface area is linked to the term to a three-dimensional object only, right? It's linked to only three-dimensional objects, and when dealing with two-dimensional objects, we're just talking about area, right? So surface area, we always thinking about a 3D shape, right? And the answer will always be in square units, meaning that if it's centimeters, then it should be centimeters square, right? And also, to find the surface area of a 3D object is to find the total area taken by the net, right? So that's very important. By the net 3D shape. And what the 3D shape looks like when it's flat in form, right? So for instance, we have a rectangular prism here, and this rectangular prism, they say to us, we must find the surface area. What would that mean? When you have to unfold it, right? It would mean that you would have calculated the area of the top part, the back part, this part, the bottom part, the front part, the ends, and both the ends. So you would have calculated all that area together, and that would have given you the surface area of the rectangular prism, right? So when asked a surface area question, it is important to be clear, right? It's important for you to know or to be able to identify and see whether or not one of the pieces is excluded or included, meaning that it is open or closed, right? So whether the shape is a closed figure or not. In other words, it may be a box with without a lid, right? It's a box without a lid, and stuff like that. This will affect how your answering should happen, right? Because then that would mean that there would be one piece of area that you do not include, and you'd only count one, two, three, four, five instead of everything else because it's open, right? And so, for example, considering the diagram of the water through a throw made in the shape of a triangular prism, to find how much metal should be used to make the throw would be the same, right, as being asked that what is the surface area. However, it needs to be noted that that it is open at the top, right? Because remember, this is where uh, the, the opening is, and missing this rectangular that has been at the top to form a closed prism, right? So when we unfold this, right, you'd find that there'd be two rectangles and two triangles, right? Why? There's this one on the side, and then there's that one on that side, and then there's a rectangle, a triangle there, and a triangle there. But at the top over there, it is open, right? And so we have this. So when we want to calculate the surface area now, what we need to do first, we need to first find the height of this. We need to find the length of this, right? And so how can we find the length of this? If you think about it, what is this equal to? It's actually equal to the length of the rectangle side, right? Or the hypotenuse of the um, of the triangle. Sorry, it's equals to the longest side of the triangle, which is the hypotenuse. But now, if you think of it going back here, we were given that this is 40 meters, 40 centimeters from there to there, meaning here we could say this is also 40 centimeters, right? But when we have separated it or unfolded it, then the 40 centimeters would be there. And 40 centimeters, when you're converting it again, it's 0.4 meters, right? And so then you'd have your 0.4 meters and your 25, right? And 25, why? Because it's the half. It's the half. Remember, this perpendicular height here cuts this triangle in half, and so then we find our height, and that height would be the value that we would multiply with 1.8, right? So there we find our surface area calculation, and that's how we would find our answer. And so here's something that's actually quite interesting. When we're looking at a cylinder, in actual fact, you need to notice that it's actually the area of two, right? It's the area of two circles, right? And then you add by the length times breadth of the rectangle. But now look at this. If you think about it, if you had to cut this circle and open it up, it would fall directly on top the length of the rectangle. So if the circumference is the same as the length of the rectangle, that's why we would say that 2 pi r is the length for that rectangle in a cylinder, right? And that's why we would actually find that our final formula when we're looking for um, surface area is 2 pi r squared plus 2 pi r times h, which is the height of the cylinder, right? And here's an example where we have the height and the radius. And so when we look at that, then we multiply and we actually find the answer quite easily, right? And that's surface area. Now, when we look at the volume, we know that this is linked to 3 dimensions, but now the difference is that when we answer, the answer should be like in cubic units and centimeters cube. And to find it, for instance, for the right angle prism, the basic formula is always to say that we're saying area of base times perpendicular height. So here are some formulas that you must have seen at least in grade 8 is the cube. So the cube is basically length times length, which is just basically length to the power 3. And then we also have the rectangular prism, which is length times breadth, which is the area of the base times the perpendicular height, you see. And then the triangular prism as well, it's the area of the base, which is a triangle, and then we times it by the perpendicular height to find the answer. And then we have the cylinder as well. It's the area of the base, which is the circle, and then we times it by height. The t here is a misprint, so times it by height. So here's an example of obviously calculating the volume of a cylinder, and you'd actually find that, you see, you have a pi r squared times h, and not the t there, and then you would find your answer quite simply by substituting it or putting it into your calculator. And then the last point is about capacity. Now, capacity is how much a liquid, a 3D shape can hold, right? And it's directly linked to volume. But here we're mostly looking about conversions moving from maybe 1 centimeters cubic to 1 milliliters, right? And so on and so forth. So here you really need to just remind yourself of how to convert from one state to another. And this just brings back grade 8 work where you need to have learned how to do your conversions quite well. Other than that, as you've seen, with the conversions part, you can stop the video and actually just remind yourself about how to convert from milliliters and so on and so forth. Other than that, I really hope that this video was helpful, and I'll see you next time.